Today's problem is creating a random password generator without using language specific internal random functions. We're going to use Python today, of course, and of course the password needs to be random, and doing that without a random function is going to be challenging. But we need some sort of randomizer function, and for this example we're gonna grab those random values from the system time, like a timestamp, I guess. Not exactly a timestamp, but let me just show. First of all, we need a character set for this demo to work. So let's just import it. Yeah, these are all small case letters, capital case letters, a couple of numbers, all of the numbers, and a couple of symbols. So let me show you what the time module does as well. Just import time, and let's just print out what time. Yes, here it is. This is the time, like current system time. I believe this is in seconds. Yeah, but we don't want to deal with the float value, so we're just going to use nanosecond version. That is, these are like nanosecond readings, I guess. From this, let's just put this all in a variable now. Something like that. Oh, okay. We're gonna have to slice a couple of digits from all of this, because as you can see the initial like 6 or 7 digits do not change very often, and of course we want our password generator to like generate a password in a relatively small time, so we cannot use like these initial numbers to like create a new random value for each character. So okay, let me explain the goal first. We are going to generate essentially a random index from the whole character set, like let's say index 27, something like z, index 40 or xyz, whatever, and we're gonna pick and choose like characters at those like generated index and put them in a single list, and that's how we create a password. To get that index, we'll pass a couple of numbers from the nanosecond string. I think it's a number right now, it's not a string. It's an integer. Okay, so to parse it, we are just going to convert this into a string. It's not going to change the output, but it's going to change the variable type. Now let's grab some digits from now, which is now string, and of course string is a like array of characters, so we can use the array functions as well. Let's just say 11 to 14, I guess. Oh, we need to print that. Yeah, so we get the characters from 11 to 14. We can also of course use negative index values, yeah. Just keep okay, yeah, hello. Okay, so it's only giving us these last 3 digits, which do change a lot every time we execute. So yeah, that's random enough, and it's like variable enough for a like a relatively quick function. Now of course we cannot use these indexes like 308 to grab an index from the character set, because the character set is smaller than 308 characters. So we are gonna have to mod our output based on the length of the character set. What modding does is restrict like the value of character index up till whatever the length of the character set is. So even if we have 308 in the like digits, okay, this side digits, so it's a string. Okay, we'll need to convert it back into an integer. There. So the final like digits will be like limited to bound by the length of the character set. That way you can create random indexes without going out of bounds, without going like out of bounds, I guess. So now we have a character index, and as a side note, let me just check my notes. I also created a small plotting function using matplotlib. Let me just try to replicate that. Matplotlib, pyplot plt plt. And let's we should be able to do all of this in a different cell for clarity, I guess. Yeah. And let us generate 100 of these. We don't need the I variable, so we can replace it with something else, but never mind. I don't mind that right now. Okay, we have a character index. Let us also generate a distribution array. We can append whatever character index we get in the distribution array, and we can use plt dot plot. Yeah, this plt dot show as well. Let us see if this works. Yeah, so as you can see, we generated 100 like random characters, but all of them were 26, like value 26, like 0 to 100, all of them were 26. This is because I'm not sure if this is a like initial internal optimization or something, but if you use time.time ns in a loop, it will always return the same value. Like this value won't change, so of course this won't change, and of course this won't change. So none of our like these variables will be they won't be different from each other. So of course in our case we got to 26. Let us try to run it again. Yeah, this time it was 33. So it's a straight line, there is no randomization. This is just a single value throughout all of our like all of the 100 runs. To mitigate that, we're gonna add a little sleep function. Sleep, and we don't need a large value. Something like this works as well, but I'm not sure how precise it's going to be. Let us check again. Anyways, yeah, there it is. There's our randomization. So throughout our 0 to 100 run, like 0 to 100 in this range, we got like a lot of variable values. And yeah, by the way, our character set is 72 characters long, last I checked. So the values range from 0 to 70. They might go above 70. I'm not sure why these, whatever. So as you can see, we get a lot of like random values. So based on this, we can assume that character index is random every time, and our like little logic here does return like random values each time. And based on this, let us create just a randomizer function. We can enter it here as well. Let's do something like generate password enough quickly. Okay, right. So like generate password. Okay, we need the length of the password. Why is the autocorrecting again? Okay. Okay. So based on the length, we'll run a loop. Length. Now let us generate the same number of characters as the length is, and let's also create an empty password list. And each time the loop goes on, we should password.append. We should add a character from the character set at the index. Character index. Remember this is the index that was generated randomly. And outside of the password, we should return our password. Okay, yeah. At this point, password is of course an array. So every time we insert a character into it, it will be a list, not a string. And let me just show you that output as well. Generate password. Let's say 12 digits. Why not? Yeah. So this is like, these are like a list of characters that we added one by one for like 12 times, so something like that. So in order to get a single string, we can use the string join function, and it should be, yeah, okay. Those might be output specific. Let us check out that. Let us import let us copy over our character set inside the function. My god, does it have, okay, yeah, it's notation problem. Okay, never mind. And just to make sure, of course, you can try it a couple of times. The passwords loop random. There are no like ABC or like XYZ or like a stream of characters like nearby, near to each other or something like that. And I don't see any problem. Yeah, we have capital letters, small letters. Of course, we haven't defined any parameters, like it should have at least a single like capital letter, at least a single lowercase letter, at least a symbol, at least a, well, not spaces of course, at least a number, at least a symbol, something like that. We can add those before calculating our character index. We can separate out our character set into a lowercase character set, a higher case character set, XYZ, and then we can generate a random number of characters to pick from the smaller case character set, another random number of characters to pick from the like uppercase character set, and then we can also randomize the internal character, the index that would be used to pick the like generated number of characters from like a particular character set. But we're not going to cover that now, maybe later. And just as a demo, let's just generate 100 passwords, I guess. Oh yeah, I figured it out. This is not like a print statement output. This is because we return whatever value, and Jupyter notebooks print it out for ourselves if we forgot to mention it. Let us try something like this here and here. Of course, we need characters. Oh, we need that. Yeah, we don't have those inverted commas anymore. 100 passwords, that's gonna take time. Take some time. But as you can see, all of these rows look independent from each other. They don't have repeating characters. I mean, a couple of them have. They don't have a lot of like related characters, 1 2 3 XYZ, like predictable stuff. A lot of them also have like symbols and numbers as well. There are a couple that do not have symbol or a number, and almost everything has a symbol and number. No, no. Yeah, so we couldn't fit 100 lines in the Python Excel, so you can check it out in another editor, text editor. So yeah, I guess all of these are random. Okay, so do not mind this. This is a VS Code specific glyph conversion. This is just okay. Let me just show that. This is just a exclamation and equal to, but if you put them right by each other, it just converts the symbol. That is VS Code specific. Do not worry about the output, like something like this. And yeah, looks good to me. Maybe we can also cover the generator with set rules. As I said, like lowercase, at least one from lowercase, at least one from higher case, at least one uppercase, sorry, at least one number, at least one symbol, something like that. But we're not going to do that now. And yeah, that's it.